There, hi. So that's basically the video was thinking about doing earlier, but we had this volcano, La Palma, going off. I noticed this area here earlier, besides those streaks what we have here. If it just would load. Get on with it. Yeah, let's stop here. There's this hull region. And I noticed that there has been these kind of strange ripples on the radar out on the sea. Like here. This kind of there has been this kind of lines. Okay. And they are somehow stationary. At least it seems that somehow they are like anchored. If you keep this point, it doesn't move at all. So I thought I'm gonna check out if there's some topographic map of the Northern Sea, but they are really hard to find, so I tried my best. And I found this, for example, that's some research gate. But I also found like there's this different kinds of maps with this kind of where is it? Here. Yeah. There is this silver pit crater somewhere. I don't know if it's this one or this one. Somewhere. It's a silver pit crater in the Northern Sea, but that's not that accurate. This map, it's really nice, looks nice, but I don't know, could be more accurate. So I found this article. Science alert. One of the tunnel valleys revealed by the seismic data, James Kirkham. So then I noticed that's actually quite new. And I tried to find some maps of the Northern Sea or Baltic Sea or whatever, like those close to Europe seas, but you don't find them. They're just not available. If you go to Google Earth, you won't see anything of the seafloor. But anyway, new imaging reveals hidden ice age landscapes buried deep in the North Sea. The hidden scars left on the landscape during ice ages thousands to millions of years ago have now been imaged in a spectacular detail. Using a technique called reflection seismology, a team of scientists has imaged enormous gorges carved by subglacial rivers, buried hundreds of meters below the floor of the North Sea, called tunnel valleys. These features can help us understand how frozen landscapes change in response to a warming climate. The origin of these channels was unresolved for over a century. This discovery will help us better understand the ongoing threat of present-day glaciers in Antarctica and Greenland, says geophysics James Kirkham of British Antarctic Survey. In the way that we can leave footprints in the sand, glaciers leave an imprint in the land upon which they flow. Our new cutting-edge data gives us important markers of deglaciation. So, I so I guess I'm not. There's no better quality of that picture somehow, but all those black things here, these are like these kind of what tunnels. What happened? Maybe I should change to desktop view. Sometimes it helps, sometimes it doesn't. Desktop site. Yeah. The weather reflection above. A map reveals the location of channels buried beneath the North Sea in an overlay showing the ice sheet limits 21,000 years ago. Okay. Limit of the ice sheet covering the UK 21,000 years ago. Yeah, but wait. Reflections as molecules and names such relies on vibrations propagating underground to generate a density profile up to significant depths. It is little like how we can use earthquakes to map the density of the interior of our entire planet, but targeted on smaller scales. In this case, airgun clusters were towed over a section of the North Sea, and these sound waves from these clusters propagated hydrophones picked up the reflections as they bounced off structures of different densities below the seafloor. Researchers then cleaned up and analyzed the high-resolution 3D data to build a layer map of the ancient landscape. One of the tunnel valleys revealed by seismic data. First of all, I don't understand why it's a tunnel. Why tunnel? It's a valley. If it would be a tunnel, there would be like something on top. It would be like a cave. Otherwise, it's not a tunnel. It's just a valley. But that's just my opinion. Even buried beneath up to 300 meters of sediment, this equipment is able to capture features as small as just 4 meters. This means the data obtained is the most detailed to date on the tunnel valleys below the North Sea. The data revealed 19 cross-cutting channels between 300 and 3,000 meters wide, with undulating tall wrecks. Based on the morphology of these channels, the researchers interpreted them as tunnel valleys formed by meltwater running away underneath ancient ice sheets. They think, because of the high level of detail, these channels reveal information about how the ice sheets interacted with the channels as they formed. Since the ice sheets found at Earth's poles today are currently undergoing melting in response to a warming climate, a better understanding of this process can help us figure out of what is going on to happen on Greenland and Antarctica in the future. Yeah. So, if these are valleys where has been water flowing through, like draining out, you would expect that it would be like deeper on the end. At least one end should be deeper than the other, otherwise the water can't flow out. You know? I guess you know what I mean. Or do we have the same problem as on Mars with the Valles Marineris, which is like, in a way, the deepest point is in the middle of the valley. So water can't flow out, so water could never create the whole valley. Because water doesn't work like that. Water has to flow downhill Yeah, but actually, we can't see anything of that except dendritical patterns. And dendritical patterns here. They look like those plasma rocks, even though there's a glacier. This more granular detail will enable us to better model the hydrological system of ancient ice sheets and apply that knowledge to our current situation. The researchers, yeah, but they probably didn't take into account that the Earth pole, like magnetic pole, is shifting and also Earth can tilt its axis, which basically means if that's Earth and that's a pole and that's a pole, and if it tilts, the pole will be here and the pole will be here. So, which basically means you are then at the equator. Like people found palms and all this kind of stuff in Greenland, which has probably been once at the equator. And maybe we'll be back at the equator once in some time, because things tend to repeat themselves. There, check it out. A dragon named Svalbard. Thanks. That's all from now.